Hi, I am Amber Solberg, and this is my big data final project demo. So for this project, I created a data pipeline for collecting, storing, and analyzing bikeshare user data from CitiBike in Jersey City. Here is the CitiBike website, and as you can see, CitiBike is the largest rideshare company in the nation that services New York City and the greater metropolitan area. As a part of the New York public data policy, CitiBike makes their rideshare data available for the public to download. As you can see, the file list is available as an XML, which ended up being useful for the pipeline, so I could get this list of files directly from the XML and automatically download them. So my CitiBike pipeline project is in my public GitHub repo linked on Canvas. This repo contains the Docker Compose YAML file that launches Nifi and Kafka instances. For the project, I used an extra large EC2 instance on AWS. The template here is just the flow template I created in Nifi, which can be reloaded later for future use. And just remember that if you load it, you have to enable all controller services manually. The last thing here is utility shell scripts to start, stop, and enter the Docker containers with ease. The purpose of the Elastic Logger tool is to source events from the Kafka stream and publish them into ElasticSearch. The first class is the log event class, which captures the schema and data coming from CitiBike. The second class is the Elastic Logger class, which encapsulates all the functionality for communicating with Elasticsearch, including creating indexes and running queries. The Task Engine class utilizes async processing and non-blocking I/O for highly efficient parallel task management in Python. Using this class, I'm easily able to run 100 or more concurrent network operations, such as posting to Elasticsearch on one thread. CLI puts everything together and allows for command line arguments to invoke the program. So here you can see I'm initializing the Elasticsearch schema and index, and now it's just going to wait for messages on the CitiBike Kafka topic. Over in Nifi, you can see I have my data collection pipeline laid out graphically. All these steps are explained in my document, but here I'm just going to quickly start the pipeline. You can see the status of all the tasks turn to green, and we can see events start flowing throughout the queues. I'll scroll down to my Kafka queue, and you can see events are starting to flow to Kafka. On the node running the Elastic Logger service, we can see that there are messages flowing through the Kafka topic to Elasticsearch. This whole process for the 1.6 million records takes about 23 minutes. However, I've compressed the process to a 30-second video clip. Once this is done, we'll take a look at the queries I've created for the Elasticsearch index. Here on Elasticsearch in the Kibana DevTools interface, I briefly run over 5 different queries. The first query is the total count of records. I think we're at 1.6 million. Second query, most popular routes by gender, 0 for unknown, 1 for male, and 2 for female. Query 3, most popular start stations. Query 4, most popular end stations. And query 5, average ride duration by user type, subscriber or non-subscriber. Over on the Kibana map tool, I created 3 different geographic visualizations. First, a heat map for popular start stations. Second is a basic mapping of start station locations filtering with both users born before and after 1970. And map number 3 is a point-to-point visual of popular routes for November 2020 with the most popular routes identified in red.